Good afternoon, all. So, in the last class, we have discussed about some of the basic terms. So, you have seen all this one, okay? Newton's first law, second law, and all. Okay, you have seen all these laws. Newton's, what are Newton's first law, second law, third law? You have to write this one. One more term you are not told. Okay, law of conservation of momentum. Total momentum before the collision is equal to the total momentum after the collision. You have written this one also, right? Okay, so next one is, that is one more definition. So this one you have understood. That is, what is momentum? Momentum is the product of mass into velocity. It is the uh, total momentum before the collision is equal to the total momentum after the collision. Okay, so these are the equations of motions. We have taken v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Okay, these are the three equations. This equation can be written it as v square minus u square is equal to 2as. V square, v means final velocity, minus u square, that is initial velocity, is equal to 2as. We have written these are the basic units and derived units. Length, mass, and time are the basic units. So, what is the SI unit for in case of SI units? Length is denoted as mass. Length is denoted as mass. Okay, that is meter, and the mass is in kg, and time is in seconds. So, these are the basic units. These units do not depend on the any other units. Okay. Next, derived units. What are the derived units? So, units of a physical quantity which are obtained from the basic quantities. Units of the physical quantity which are obtained from the basic units are called as derived units. So, velocity, acceleration, these are all of the derived units. Minutes. Okay, so have you written this one? What are the units for this one? Velocity, acceleration, momentum, force, weight. So this one you have to write it. This is important. Every body attracts the other body. That is Newton's law of gravitation. So this one is important for the examination point of view. Every body attracts the other body. The force of attraction between any two bodies is directly proportional to the masses and the inversely proportional to the square of the distance between them. M2 are the masses of the two bodies and E is the distance between them. The force is directly equal to M1 into M2 divided by D square is equal to G into M1 by M2. Okay, so what is M1 is the mass of the body 1, M2 is the mass of the body 2. So the force of attraction between these two bodies is F. Okay, so if I consider this is D is the distance between these two bodies, then as per the Newton's law of gravitation, the force is directly proportional to product of masses of the bodies and inversely proportional to square of the distance between the F is directly proportional to M1 and M2 divided by D square. Okay, this F is equal to, when you remove the proportionality, the constant you will get it is, that is G, capital letter G. So this F is equal to G into M1 into M2 divided by D square. So G is equal to universal gravitational constant. Okay, so this is important for the examination point of view. So sometimes he will be asked for the Newton's laws of motion, that is first law, second law, third law, and also sometimes it is asked for the Newton's law of gravitation. Okay, this is important. Forces. So force, what is the force? Force is the external, it is defined as an external agency which tend to change the state of rest or state of motion of a body which it acts, upon which it acts. So consider this is one body. We consider this one body. The body is in static condition. Okay. When an external agency act on it, the state of this body is going to change. When the state of this body is going to change, it means initially it was in static condition. When an external force acts, the body's state is going to change. Then such a state agency is called as force. Now take that the body is in motion. Okay. When an external force is applied, now the state is going to change. Initially it is in motion. When the external force is applied, the state is going to change. That is, it will become static. This external agency is called as what? This is force. Okay. What is the force? What is the force? Force is an external agency which tends to change the state of rest or the state of motion of the body upon which it acts. The SI unit of force is Newton, that is capital letter N. So you have to write when you are writing the scientist name in sign, you have to write it in small letters. When you are writing only first letter, then it is capital letter. As per the second law of motion, F is equal to m into A. Also, 1 Newton is equal to 1 kg of mass and 1 meter per second square. If you consider Newton, so unit of Newton is kg meter per second square. Then in case of MPA system, unit of force is kg force, kilogram force. 1 kgf is equal to 9.81 Newton. Then we will come to the characteristics of force. So whatever you are applying a force, this force is having some of the characteristics. This is important for the examination point of view. So what is defined force and what are the characteristics of force? Okay. Oh, next, first one is what? It is magnitude. What is the magnitude? The quantity of force is known as magnitude. So how much is force? So this is the body. You are applying the force. So how much you are applying? Whether you are applying 1 Newton, 2 Newton, 10 Newton, 20 Newton, how much? That quantity represents the magnitude. Quantity of the force is known as the magnitude of the force. Example, if I consider a force of 25 Newton, it means that 25 Newton is the magnitude of the force. Okay, and one more is second one is point of application. So when this force is applied, where it is applying, whether you are applying it this point, this point, this point, this point, this point. So the point at which the force is acting is called as point of application. Point of application. The point at which the force acts is called as point of application. Okay, this is important. Point of application. Next third one is line of action. The line of action along which the force is acting is called as direction of the force or line of action. So this is the force of action. So when you consider this is a line of action, so its line of action is like this. Okay, if there is no body, then it will move on like this. So this is line of action. So the line of action along which the force acts is called as direction, or it's also called line of action of the force. That nature. So nature, the nature of the force is indicated by push or pull. Okay, push or pull. What is push or what is pull? So consider this is a body. Okay, this is a force. Now this force is applying towards the body. Then this force or the arrow of the force is acting on the towards the body, then the body is in push condition. It is push. When this body is applying moving away, the force is moving away from the body, then that is called as pull condition. So always there are two nature of the forces. One is push condition and one more is pull condition. What is push condition? If the arrowhead of the force is directly proportional, or you can say if arrowhead of the force is directed towards the point of application, then it is called as push. So this is the force body, this is the force, there is a point of application. So when the arrowhead of the force is acting towards the directed towards the point of application is called as push. Okay, is called as push. Next, what is pull? Pull is the arrowhead of the force is directed away from the point of action, then the force is called as, then the nature of the force is called as pull condition. Then the nature of the force is called as pull condition. When this is the body, when this arrowhead is going away from the force or the point of action, then that is nature is called as pull condition. Clear this point of, that is characteristics of the body's forces. First one is magnitude, next one is the point of application, line of action, and nature. Whether it is in towards the point of application or away from the point of application. These four are the some of the characteristics of force. All of you read on this one. So first one is magnitude. The quantity of force is known as magnitude of force. Force of 25 newtons. 25 indicates the magnitude of force. 25 indicates the magnitude of force. Next one is point of application. Point of application. The point at which the force acts is called as point of application. Point of application. Next, line of action. Line of action. Line of action along which the force acts. Along which the force acts is called as direction of force. Is called as direction of force. Next, nature. Nature of force. The nature of force is indicated by push or pull. The nature of force is indicated by push or pull. What is push? First one is push. If the arrowhead of the force is directed towards the point of application, if the head of the force is directed towards the point of application, then the nature of force is push. Then the nature of force is push. Second one, pull. If the arrowhead of the force is directed away from the point of application of then the nature of force is pull. Okay, these are the two nature of the forces, push and pull. So these are the basic or the characteristics of forces important for the examination point of view. Okay, that's what I have written: magnitude, point of application, line of direction. So next is classification of the forces. So classification of forces, there are basically different classifications. So you have to remember, this is important for reason. Most of the papers there is a question explaining the classification of force system. So it will come for the 6 to 8 marks. Okay. First you have to draw this flow chart. forces. So force system. So this force system is divided into two per type. One is coplanar and one more is non-coplanar. This coplanar force system is again bifurcated into some different parts. One is concurrent and non-concurrent. Coplanar force system again bifurcated into different types. First one is coplanar or non-coplanar. Coplanar or concurrent and non-concurrent. Concurrent and non-concurrent. Second one is collinear, non-collinear. Collinear or non-collinear. Next, parallel or non-parallel. Parallel or non-parallel. Next, like or unlike parallel. Like or unlike parallel. Okay. So in the whatever you are having the types in coplanar force system, that is concurrent, non-concurrent, collinear, non-collinear, parallel, non-parallel. Okay, this time in the parallel again there is like parallel, unlike parallel. We will see the examples. With examples we will discuss. Okay, so all these types are there in the non-coplanar also. Non-coplanar, concurrent, non-coplanar, non-concurrent. Okay, all are there. Okay, we will discuss one by one later. Okay, these are the definitions. So these are the different forces system, their characteristics and their examples. So instead of going through these definitions, first we will see the examples, that is with figures. You will clear the all the definitions. By looking at the figure, you will come to know, you will have to decide the definitions. Okay, see, first now this is in only one box. That means this is one plane. Okay, so this is one plane. Okay, all the forces are acting in one plane. Then that is called as coplanar forces. Then this is F1 force, F2, F3, F4, F5. All these Fi, so all the 5 forces are acting at the one point. Then this is called as concurrent force system. So this is coplanar force system as well as the concurrent force system. Why coplanar? Because all the forces are lying in the same plane. That's why it is called as coplanar. And why it is concurrent? Because all the forces are meeting at one point. Correct. So all our forces are meeting at one point or acting at one point. Then such a force system is called as coplanar concurrent force system. Okay. Next, second one. See, there are F1, F2, F3, F4. There are 4 different forces which are acting in the only one plane. Then this plane is nothing but coplanar plane. Coplanar force system. Whether these are concurrent or non-concurrent. So these are not a concurrent. All the line of action of the forces are different. Okay, this is different. This is different. This is different. So this is non-concurrent. Okay, coplanar but non-concurrent force system. Next. This is collinear. If all the line forces or the line of action of the forces are lying in the same line, then that is called collinear force system. If I consider the one more force here, so this is what how it is. It is in this direction. Okay, so you consider this is one more direct forces. You consider this is, and if I write it is F1 force, F1 force. This is F2 force. F2 force. This is F3 force. Wait a minute. Okay, these are the different force systems. See, when you come, this is collinear because all the forces are the lying in the same line. It's called as collinear. What about this one? This force is in the same line, but the third force is not acting on this along the same line. It is in a different line. It means all the forces are in the same plane, coplanar forces, but non-collinear. Coplanar, non-collinear force system. Next one is coplanar parallel force system. See, all the forces are acting in the same plane, but 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 they are not in the they are parallel to each other. So all the forces are acting in the same plane and they are parallel to each other. How they are parallel? Either like parallel or unlike parallel. One force is moving downward, another force is moving upward direction. It means they are unlike parallel force system. Unlike force system, parallel force system. All the forces which are acting on the same plane and they are parallel to each other, but they are opposite in direction, to each other. So there, such a force system is called as coplanar parallel force system. Next one is all the forces are acting on the same plane. Okay, they are parallel to each other. They all are moving in one direction. Then such a force system is called as coplanar like parallel force system. Coplanar like parallel force system. All the forces which are acting on the same plane, and which are parallel to each other and moving in one direction, such a force system is called as coplanar like parallel force system. Okay, these are all 6 examples for the coplanar force system. When you are coming for the another non-coplanar force system, here what it is, how it is there. So there is x-axis, y-axis, and z-axis. Any force which is acting in the space is called as non-coplanar forces. Any force which is acting on the space is called as non-coplanar forces. See, all the forces, there is the force is acting on non-coplanar, but is it parallel to each other? Yes, these are parallel to each other. Whether they are in the same direction or opposite to each other, they are in the same direction. So this is non-coplanar like parallel force system. Non-coplanar like parallel force system. If any one of the forces opposite in direction, then such a system is called as non-coplanar unlike parallel force system. Non-coplanar unlike parallel force system. Okay, that are the two different. Next, one more force. So this force system is also a force is acting in space, or it is in non-coplanar along x direction, y direction, and z direction. Okay, this is one force. Another force, all the forces are different. Okay, all are in the non-coplanar forces, but all the forces are acting from the one single point. Then such a force system is called as concurrent force system. Non-coplanar but concurrent force system. Okay, this is non-coplanar concurrent. Next one. So next one is also a non-coplanar because there is the x, y, and z axis, but all are there. This is non-coplanar, but there are different forces, but all the forces are not acting at a one single point or not starting from a one single point. Then such a force system is called as non-concurrent force system. Okay, clear? Non-coplanar, non-concurrent force system. Okay, these are the different types of force systems. So when you're looking at the figure, you will clearly idealize which type of force system it is. Okay, by looking at the figure only, you have to read the definition of all the force system. First one, read on collinear force system. Collinear force system. Okay. Collinear force system. Line of action of all the forces. Line of action of all the forces act along the same line. Act along the same line. Right, this is the image. This is the figure. Right, this is the image. Okay, figure. So collinear force system. Okay. One force is acting in this direction, another force is acting in this direction. If you consider one more force which is acting in this direction, but all the line of action of the forces are in the same line, then this is called as collinear force system. Next, write down second one, coplanar parallel forces. Coplanar parallel forces. Coplanar parallel forces. Law of all the forces. all the forces are parallel to each other. All the forces are parallel to each other and lie in a single plane and lie in a single plane. Okay. So coplanar parallel means what? All the forces are parallel to each other and they are lying in the same single plane. It's called as coplanar parallel force system. So what is the example? Example is this is coplanar parallel force system. This is example. Okay. So all the forces are acting on the same plane and they are parallel to each other. So parallel forces. Whether it is like parallel or unlike parallel, you can differentiate. Okay, depending on their direction, moving direction. Just I am writing coplanar parallel force system. This is the coplanar parallel force system. And draw all these diagrams also. So write all the diagrams. We will explain one by one. Then we will define it. Right? All of you write the drawings. Okay, just on the diagrams. So remaining definitions we will see in the next class. Okay. Thank you.